Hello everyone. Today I'm going to talk about the latest model from Alibaba Cloud, which is Qwen2.5 Omni model with 7 billion parameters. This is a multimodal model, and the specialty of this model is that it can take text, image, audio, and video as an input and process them and produce text and audio as an output simultaneously. Let's find out how can we access and use the model, and also how can we integrate it programmatically. Let's find out how can we access this model and how can we use this. So to access this model, you can directly go into this URL chat.qwen.ai, and once you go there, you can select the options to choose the model. So you can find out, let's expand more models, and if I expand that, then at the end I can see that Qwen 2.5 Omni 7 billion models. So if I select this one, this is already selected for me, so you will get this option, and then if you click on this symbol, you will get to choose voice and video chat. So let's start with the voice chat. Hello, can you please introduce yourself?
Hello, I am Qwen, a large-scale language model developed by Alibaba Cloud. How can I assist you?
Okay, I have a question in mind. That is, do you think open source large language models can force closed source model providers to change their business strategy?
Well, it's possible that open-source large language models could influence other companies to change their business strategies. For one thing, if an open-source model is really good at what it does, like providing accurate answers or creating great content, other companies might see it as a threat. They might start thinking about how they can either improve their own models or find ways to work around them. Also, if there are legal issues related to using proprietary technology in certain areas because of these open source models, that could force changes too. But it's not going to be easy for them to just force others to change completely. There's still a lot of factors at play, like market competition, customer needs, and technological limitations. So, yeah, it's definitely something to consider. What do you think about this? Do you have any other ideas or questions related to it?
Yeah, how do you compare ChatGPT from OpenAI with DeepSeek R1 or Qwen 2.5 7 billion models?
Well, ChatGPT from OpenAI has some advantages over DeepSeek R1. ChatGPT was trained on a huge amount of data, which gives it a wide range of knowledge and the ability to generate more diverse responses. It also has been fine-tuned for natural language understanding and generation, so its interactions feel more human-like. However, DeepSeek R1 has its own strengths too. It might be better at handling specific tasks or having a different focus area compared to ChatGPT. But overall, ChatGPT seems to have a broader reach in terms of general knowledge and versatility. If you want to know more about their differences in specific use cases or technical details, we can keep talking about it.
Oh, that's fine. I just want to also show that if we want to change the different speaker,
Hello, I am Quen. Is there
that
anything you'd like to share?
Hello, I'm Qwen. Is there anything you'd like to
that
share with me?
different four speakers.
Hello, is there anything you'd like to share with me?
So you can change to Ethan,
Hello, I
Chelsea.
am Qwen. Is there anything you'd like to share with
Hello.
Hello, can you describe my background?
Well, it looks like you have a computer set up in your background. T here is a monitor on the left side with some code or text displayed on it. Next to it, T here is a microphone standing upright. On the right side, there seems to be another device, maybe a laptop or something similar, along with a keyboard placed on top of what could be a book or a folder. The wall behind is plain white. What do you think about this setup? Do you use it for work or study?
Yeah, I use it for work.
Oh, that sounds interesting. So if you're using it for work, it must be pretty handy. Maybe you're coding or doing some other tech-related tasks. What kind of work do you usually do here?
Thank you. let's find out the key features of this model. So here it is mentioned that this is a unified model that can perceive all modalities and simultaneously generate text and natural speech responses in a streaming fashion. So this is the first point I mentioned when I introduced. So this can simultaneously generate text and natural speech responses. And second is that this present a novel positional embedding algorithm termed as TMROP. So this stands for time aligned multimodal rotary positional embedding. So rotary positional embedding is an existing algorithm. So they have modified that based on time aligned, and which explicitly incorporates temporal informations for synchronizing audio and video. And finally, the thinker-talker architecture to facilitate real-time comprehension and speech generation. So this is the thinker-talker architecture. In this diagram, we can see that this is the main model, which is actually take image, text, audio, and video as an input, process them, generate high-level representation of the text and also the sample embedding tokens, and that is provided to the talker with those tokens. It further process them and generate the speech simultaneously. So this is in a very simplified way this can be described. And if you want to more about that, then I would suggest that follow this paper published by Alibaba Cloud. Let's start with the coding part. Before I start, I would like to thank Hugging Face for providing the sample code to execute, and I have strictly followed whatever they have mentioned as a prerequisite. And I have first so I have executed the code in the virtual environment where transformers were not installed. So first step was unnecessary for me. I installed the transformer from this particular link, and then I installed accelerate. Finally, they have recommended to install decode from Qwen Omni utils, and this didn't happen for me actually. It didn't throw any error in the beginning, but when I was executing the code, it was mentioning that decode is not here. It is not able to work with this version of code, and it was defaulting back to another package that is called Torch Vision. So what I did, I just followed this step. So though I am executing my code in Windows subsystem of Linux, but still I believe this didn't work for me. So I followed these steps. Like if you are not using Linux, you might not be able to install decode from PyPy. In that case, you can use pip install Qwen Omni utils, which will fall back to using Torch Vision. This was happening for me. However, you can still install decode from source. So this is the source, and then I just followed the step for Linux what it has been given. So the first step was to install ffmpeg4 package, which I didn't actually. This was installed, and I just followed this step to clone the decode package, and then I followed these two steps. After that, I just ran the CMake with CUDA on and DCMake build type release. And after this, I thought that thing is over, but no, it failed again. So this GitHub link has everything mentioned. It means where it can fail. So I have used so my CMake was failing with this particular package. It was not able to locate this package. So they have mentioned that how can you find that package. So I just executed this command and I found out where that package is, and then finally I linked that package to CUDA toolkit root directory /leaf64 folder. And once I linked this, then CMake command ran successfully, and then I followed this command cd /python, just one folder back from decode, and then I just followed these three steps, and finally this was done, and when I executed my code, then it was not failing with that warning like decode is not there, so falling back to torch vision. So this particular problem didn't happen. Finally, I ran the code, and I also followed the recommendation there, like we recommend enabling flash attention 2 for better acceleration and memory saving. Unfortunately, this didn't work for me. I don't know why, because I have followed their step to install flash attention package, which is so I followed this step to uh, install the flash attention, which didn't work for me. So my code was falling back to the original code without flash attention. And for the example demo, I have used this particular video, the default one which was given here. I'll just show you before executing the code. And yeah, this one, the draw.mp4, which I have just opened the link for you. And then I ran for another example, that is this image I have given as an input and got the voice back. So these are the two examples I executed. I will not execute it now because when I executed this, it took a long time for me to execute, I think around 15 minutes. I don't know why it took so long, because this is a 7 billion parameter model and I am executing on a 24 GB GPU. So this is RTX A5500 model and this is 24 GB GPU memory. I'll just to give a demo, I'll just run that for a minute and I'll show you like how much memory is actually taking to execute this kind of example. It is more than 24 GB it is consuming. So this is all, and I'll just go to the coding part now. So as mentioned earlier that these are the main packages have been used here: transformers, then Qwen Omni utils, and then torch and sound file. This is the logging info I have just kept because it was failing initially for a number of times. So just to understand the log, I have kept it. And this is another thing which I introduced here, which was not there in that particular code, just to check like whether I am using CUDA or not, means GPU or not, because initially my code started failing and then I realized that okay, this code is not using the GPU and it is using the CPU, and that's why it is failing with the memory constraint after running for a long time. And the main issue was that I realized that the CUDA library, the PyTorch library was not installed. So I installed that and then that started working. And you can see that I have initialized the attention implementation. So this is the flash attention 2 package, but from this code you can just see this is not working, like you are attempting to use flash attention 2 without specifying a torch D type. So even I tried with specifying the torch D type as well, that bfloat 16, but you can see that I have commented out because even after giving that, it was still failing, actually failing in the sense like it was not using the flash attention. So main reason is that this might lead to an unexpected behavior. This Qwen2 50 million token web model must inference with FP32, but flash attention 2 only supports FP16 and BF16. So it was not using the attention implementation. I think that flash attention 2 doesn't support FP32, and that is the main reason it was not using the attention implementation. And then finally, this is the processor which will process the input, and this is the standard conversation which I have taken from the Hugging Face example. And this is the system prompt, and where actually we are mentioning that you are Qwen, a virtual human developed by the Qwen team, by Alibaba Group, capable of perceiving auditory and visual inputs as well as generating text and speech. And then as a user prompt, I have used two examples. So for the first one, it was like video, and this is the location of the video. And then the second example was image, and this is the location of the image. So I'll just show you like how the input and output is. So for the first one, as I mentioned that this is the input video. Let's start this one.
Hello, take a look at what I'm drawing.
And let's go back to the output of that.
That's a really cool drawing. It looks like a guitar. You've got the body and the neck drawn in a simple yet effective way. The lines are clean and the shape is recognizable. What made you choose to draw a guitar?
So this was very clear description. So it had processed both audio and video, and finally it has given the audio output, and when I executed that, there was a text output as well along with this audio output. And the second example was the architecture diagram. So what I have done, I have just taken this architecture diagram from the Qwen technical guide, and then I have given that as a input to this. And let's find out what they have. So you can see that. So yeah, this is the output. This diagram is showing the architecture of the Qwen 2.5 Omni model. It has a vision encoder and an audio encoder at the bottom. The vision encoder takes in images and the audio encoder takes in audio signals. Then there is a Qwen 2.5 Omni thinker in the middle. This is where the main processing happens. It takes in text tokens, vision hidden states, text hidden states, audio hidden states, etc. The whole model is designed to handle multimodal inputs like text, vision, and audio. So what do you think about this model? So if I run this one, it will say the exact things.
Well, this diagram is showing the architecture of the Qwen2.5 Omni model. It has a vision encoder and an audio encoder at the bottom. The vision encoder takes in images and the audio encoder takes in audio signals. Then, T here is a Qwen 2.5 Omni thinker in the middle. This is where the main processing happens. It takes in text tokens, vision hidden states, text hidden states, audio hidden states, codate tokens, codate hidden states, and pad hidden states. T here is also a Qwen coded decoder at the top. It seems to be responsible for decoding the output. The whole model is designed to handle multimodal inputs like text, vision, and audio. So what do you think about this model? Do you have any specific questions about it?
So I would just like to say this has perfectly analyzed the first example where it was the artist was drawing a guitar, means completing a guitar diagram, and then in the second example, this was just a diagram of its own architecture, and it has perfectly analyzed that. Only thing probably it has missed that I forgot to mention that Qwen 2.5 Omni Talker, if it could introduce this particular information as well, then I think this information probably would have been complete. So with this, I would like to conclude, and I would like to mention that this is a beast. So I think this is one of its kind. I haven't seen any model so far which can produce text and audio simultaneously as an output. I'm sure that probably a lot of other models will come in future, but this is just the start, and Qwen has proven that open source model is becoming stronger by day. And with this, I would like to conclude, and I'd like to thank you very much for watching this. And in the end, I would like to request to please subscribe and like, and don't forget to put your comments and feedback. Thank you.